This is about Motek tutorials. You can follow us on LinkedIn and find the tutorials on our YouTube, and please have a look at our knowledge platform as well. This is our disclaimer. These are not replacement for a training or certification process. So we would like to help our users better understand how we can do all these kind of, for instance, complex tasks. They seem quite simple, but they're quite complex in balancing a stick, for instance, on a platform. So this can be possible with just these three options like motion capture, D-Flow, and platform. And this is the D-Flow software environment that you can do these type of things, plus the hardware, of course. Some examples, more examples would be like walking at the sea, or for instance, finding or detecting an event here, gate event here, or for instance, perturbation. So someone is walking and you want to perturb them using a third-party device or joystick, or different types of gate and balance, uphill, downhill, and you collect data, all sort of data like dual tasking. You see that this person is doing dual tasking, being perturbed as well at the same time. And in the virtual reality, he or she is immersed as well. So D-Flow is a software system for real-time interactive immersive virtual reality applications, and more specifically for clinical purposes or rehabilitation, but they're not just these applications. You can find them, our users use them quite different, what do we call it, applications. Here, for instance, see the game being developed by Motek. And here are some of the features of D-Flow software can be used in biomechanics, neuro-mechanics, psychology, and so on. The applications are huge. What we want to do in these tutorials are we would like to go through project-based learning. So what we actually come up with an idea. It comes from you guys or comes from us mainly, and then we build around that. So feel free to take any of these ideas and expand them. You want to talk to us, and if you need any help or expand upon them, please let us know. I would be happy to share these simple applications in our knowledge platform as we go. So usually the way things work in research and development, this is one way we look at it, is like we study design, talk to colleagues, yourself, read the literature, and then you go and collect data, would be feasibility study or preliminary study, and then you take it, if that's okay, then you take it to, for instance, the lab or real experiment. And this is usually an ongoing process. It's not going to finish this way, right? So what our purpose here for tutorials or video tutorials would be just around this part, which is more of an emulator. We are using our system and our software to help you understand what the possibilities are. And please feel free to get back to us in any comments or suggestions that you may have. Some of the tutorials that we have been creating for you so far, you can find them, for instance, with different types. For instance, if this is working like post-processing, like Max file, or say, for instance, using a VR or Blender, other software packages, and how you can create 3D models and bringing them into D-Flow, perturbation type of things, feedback or biofeedback, or even if you find a journal paper that you want to reproduce, how you can do them quite quickly in D-Flow. So these are the quite many possibilities. Please find what we do and follow us on social media and our YouTube channel, basically. So feel free, as I said, give us any suggestions or comments so that we can improve this work. So quickly give you an overview of one of the devices, and this is a Karen system at the University of Melbourne. So they have done quite cool 3D model of it. So you can see here, this is a platform, the treadmill on it, and virtual reality will be projected here. We have got cameras around here, we've got projectors here, and even the sound system, everything being controlled by these computers. And you can see there's quite a lot of things you can do with this. Is a 6 degree of freedom platform or robotic system. And this VR can change, and these cameras can help you get, for instance, the motion of a person standing here. You can do all sort of experiment. One quick applications, for instance, that I can build here to show you what are the possibilities, and then you can keep watching our videos. For instance, imagine you want to have, this is an emulator of what you can see here, right? Just bring them here so that you can see. Let's say you would like to have the platform, this platform here is exactly this platform, okay? And you want to move it, all right? So you just use a generator, and then you give it X and Y, and the generator will get any sort of functions, mathematical functions, all right? When you run this system, so engage the system, you can see what's happening. Can you see that? Isn't it cool? And it's real time. And exactly what I do here in the emulator, you can do it in the simulator, in the actual device. Or for instance, if you want to have, let's say, treadmill here, and then you want to change the speed of the speed of the treadmill, and you bring, I would say, evaluator. This is actually a cool thing. You can give it to the treadmill, and then you give the parameters. You can, for instance, give the belt speed. All right, you can actually have separate belts because it's dual instrumented treadmill, so you can have different speeds. So that would be perturbation type of things. And then if you look at it, because I don't simulate it here, I emulate it here, I can bring, for instance, a kind of graph, right? All right, and that graph can go 3D graph, okay, can go back so that we can see what's happening here, right? I clear things for you, and then in the meantime, that would simulate this VR examples, okay? And if you turn on your what you call it, treadmill, and then you change it, this is 0, all right? You can see that this is changing, and we haven't given it, so I just wanted to give the endpoint of this to the treadmill, right? To what you call the graph. And if you do that, you would see that the changes happen here. So I can actually delete most of these. Let's just give you one example left, for instance, belt. And you can see the changes that happen. Do you see that? In the meantime, real time. So we created real time emulation of this big system. And you can do also the application and then understand what could happen, and then take it to the lab as we discussed. Hopefully this would be of your interest, and let us know if you have any questions or suggestions.